When you hear the word physics, what comes to mind? Complex mathematical algorithms? Sleepless nights spent crying because why can't you just pass one exam? There are many ways when physics can be something fairly awesome. Today, we will cover the physics behind collisions. Collisions seem simple. What else could be going on with crashing things? A lot more than you'd expect. If we want to understand how things collide, we have to break collisions down. What even is a collision? Let's start by explaining Newton's laws of motion.
Law 1. An object at rest tends to stay resting. An object in motion will stay in motion. Keeps going at the same speed and direction.
For example, if you roll a ball towards your baby brother, the ball will want to keep moving, even if your brother doesn't catch it. If your baby brother catches this ball, congratulations! Your brother has now been upgraded to a force causing an object in motion to stop moving. But why does the ball stop?
Law 2. An object with more mass takes more force to move. Force equals mass times acceleration, so you must kick the ball harder to have the same conclusion.
A ball, like any moving object, has a mass, the amount of stuff that makes it a ball. It's not the same as weight, as mass always stays the same no matter where you are in the universe, but weight changes based on gravity. When a ball, a mass, moves, this is acceleration. Acceleration is a change in speed, so going from rest to moving means the speed has changed and, therefore, acceleration has happened. If this is true, then one can also conclude
The third law of motion states for every action there must be an opposite and equal reaction. So when that ball is kicked, one force will be it. The other force is the ball is the opposite direction.
as the ball moves towards your baby brother, notice how it slows down. Why? A force is acting on it, friction. Friction is the force that works against this ball, causing it to slow down and eventually stop. If you push the ball enough to that it stay moving long enough to reach your brother, then when your brother catches the ball, he is applying his own force to stop the ball. If it's strong enough, the ball will stop. If not, he better watch out. Newton's laws of motion apply to collisions. They are the reason collisions happen. When a car is moving, a car doesn't want to stop unless a force acts on it. This may mean something as simple as braking or collision. So how much force should we apply to make an object come to a stop? This is where a thing called momentum comes into play. Momentum is the object's ability, while moving, to be able to stop. A little ball moving at slow speed wouldn't require much force at all to stop. A high-speed freight train could. Remember, the higher the momentum, the harder it is to stop. If momentum is the object's ability to remain moving over a certain speed and time, what happens if this changes? What happens if our moving ball slows or speeds up? This change is called impulse. In other words, impulse can be seen as a moment of collision. We finally reached collisions. But what exactly is a collision? Surprisingly, you can describe them in two ways: elastic collision and inelastic collision. Elastic collisions are bouncy like hair elastics. When an object hits another, that other takes on the speed of the object. The object that did the hitting loses every single bit of its speed in the process. These collisions are actually rare to come by in real life. Inelastic collisions is the opposite. No speed is lost in a collision. There is one truth of inelastic collisions: the system's momentum is always saved. IT may change into different energies, but IT must always be saved. If inelastic collisions are more realistic and follows Newton's laws, surely there must be an example where every single thing goes perfectly right, huh? Introducing perfectly inelastic collisions, the opposite of being bouncy, essentially, in which the colliding objects, well, stick together. Every bit of speed is turned into heat, sound, or anything else that doesn't increase their speed. Momentum is still conserved. The mass of the objects combine as one and their momentum increases, meaning not only is it harder to stop moving, but it typically slows down. To review, an object, by default, wants to move and will do so as long as no forces act opposite to it. The force needed to stop an object in moving is called momentum. We find this using the object's mass and how fast it goes. The change in momentum is called impulse, the change in the force needed to stop a moving object. When two things collide, one of three collisions can occur. Elastic collisions, when one object loses all its speed energy and gives it to the object it hit and no longer saving momentum. Inelastic collisions, when objects collide and save momentum perfectly. Inelastic collisions, when objects not only collide and save momentum, but stick together and become one whole mass affected by a combined momentum. While I don't endorse you get into car accidents, watch an action movie or a crazy stunt scene and think to yourself, how am I seeing physics in action?